Welcome to the world of DNA. This movie will show that DNA is complex and difficult to make by random chance. DNA is an abbreviation for deoxyribonucleic acid. DNA provides blueprints and instructions to build and operate all living things. In the next few minutes, I will show you how to make models of simple molecules and DNA by random chance. My models will be made of styrofoam balls and wooden sticks. All DNA is made from just nitrogen, oxygen, carbon, hydrogen, and phosphorus atoms. First, I will make 3 simple molecules, and then I will make 1 nucleotide of DNA. Good evening, ladies and gentlemen. I'm going to talk to you today about DNA, which is an abbreviation for deoxyribonucleic acid. And we're going to do some modeling to make some molecules and show you how that DNA can be made by random chance modeling. My assistant is here. She's going to bring me the first project. My first project, I'm going to make a model of ordinary water, kind of stuff that falls from the sky when it rains. You need 1 atom of oxygen. We need 2 atoms of hydrogen. We put them into the fancy, high-tech, random modeling machine. Thus, turn it over carefully so that nothing escapes. Then what we do, we shake the random chance modeling machine, and presto, changeo, out comes 1 molecule of water. And you see that the oxygen atom is bonded to 2 hydrogen atoms. Okay, so we take all of these toys and we put them back in the magic random machine modeler. And now we're going to do example number 2, which is going to be ammonia. So Melody's going to bring me 1 atom of nitrogen and 3 atoms of hydrogen. And we're going to take these, you know, it's empty. It's empty. We put them into the magic modeling machine, and we turn it over, and we shake it and we shake it, but we try not to break it. And out of the random machine comes, not enough shaking. Okay, more shaking. And finally, ta-da! 1 molecule of ammonia with 1 atom of nitrogen and 3 atoms of hydrogen. For our next example of random chance modeling, we're going to make a molecule of natural gas, which is the scientific name for natural gas is methane. We have 1, 2, 3, 4 atoms of hydrogen and 1 atom of carbon. And we turn the magic machine over, and we shake it and we shake it and we try not to break it. Giving random chance takes a little longer to make methane because it has little pieces. Bring it around, and here we have 1 molecule of methane. You'll notice that there is 1 carbon atom and 4 hydrogen atoms. This is random chance modeling of methane, water, and ammonia. Now we're going to put these toys back in the box. And now that you understand how random chance works, we're going to try to make a piece of DNA, which is an abbreviation for deoxyribonucleic acid. Okay, now that we have made random chance models of water, ammonia, and methane, we're going to attempt to make a random chance model of DNA. Bring me a bunch of atoms and put them into the magic random chance modeler. Thank you, thank you. So we're gonna take it, but we're not gonna break it. And we turn it over quickly. Shaky, shaky, shaky. Okay. I'm too old for all this shaking, so we're bringing in a special shaker. Her name is Melody. She's going to shake the random chance modeler. And I'm going to go and take a little break. And when you get this nucleotide, when you get a nucleotide of DNA, then call me and I'll come back. I'll take a little break. Gotta keep shaking. You can't get nothing done if you don't shake. Okay, let me look at this thing. So you think this is a piece of DNA?
I think so.
Okay, you got one phosphate, you have one deoxyribose sugar, and you have one molecule of cytosine. You have one nucleotide of DNA. That's remarkable. Okay, this is one nucleotide. If we were going to make my DNA, you would have to have the other side, so you would have to have one over here. So you need 3,164,700,000 long and 2 wide. So you would have to have a little over 6 billion nucleotides. And since there just happens to be 6 or 7 billion people in the world, so if everybody in the world brought a nucleotide to Kansas, and we could just kind of like go back and forth across Kansas a few times, or as I said earlier, we could go just all the way around the world 42 times, then we could make one copy of my DNA. Now in my body there's probably 75 trillion copies of my DNA. That's not billion, that's trillion. If it's $75 trillion, we could pay off the national debt and just throw money around. In my opinion, making that much DNA from a random chance variation with survival of the fittest probably just didn't happen. But you have to make that decision for yourself. So here it is. This is one of the 4 nucleotides. This is C. There is an A, a T, a G, and a C. Of the 4, this is the simplest one. I did the simplest one first because it would be the easiest. Okay, so there's my demonstration on random chance modeling of DNA. And you have to decide, is it random chance or did God just sit down and make this stuff? Thank you for your good attention. Now we're going to do a 2-minute review of this video. We will look again at the 3 simple molecules we made with the styrofoam atoms: water, ammonia, and methane. These molecules can be found in our solar system. The Earth has large amounts of water. Mars has frozen water in its polar regions. Jupiter has white clouds of ammonia in its atmosphere. One moon of Saturn has so much methane that methane sometimes rains from the sky. The DNA nucleotide for cytosine is very complex. It is difficult to make by putting simple chemicals in a beaker of water and heating it or adding a spark of electricity. Scientists have been trying this for many years. An article in Scientific America has summarized these attempts. No nucleotides of any kind have been reported as the products of spark discharge experiments or in studies of meteorites. The nucleotides are particularly difficult in my mind because of the double bonded nitrogen atoms attached to carbon atoms, not something you find in a typical molecule. Thank you for your good attention. Again, I invite you to take a careful look at the complexity of DNA and make your own conclusions. Thank you.